Now, I'm going to work on the assumption that we're all fairly good at the basics, and you don't need me to be showing you how to multiply out complex numbers, how to divide complex numbers, that you need the more interesting bits done. Am I right? Okay, can you sign that, Dominica, please, and pass it on? If your name is not on the list, just write it at the bottom somewhere. Okay, just underneath it somewhere. So, first of all, anyway, complex numbers really starts to get interesting when we start talking about what's known as the polar form of a complex number and a theorem called the Moivre's theorem. Okay? That's when it begins to get interesting. So what I'm actually going to do is it's like as if I'm going to do the topic in reverse. I'm going to do the hard stuff first to make sure we get it done, and then the easier stuff last with whatever time we have left over. Is that okay with everybody? So we'll begin with the more interesting things. So first of all, polar form. Okay, or in the leave insert, they tend to write it as the form r into cos theta plus I sine theta. I'm sure we've all seen that a million times. Okay? Technically speaking, theta is known as arg z, the argument of the complex number. Okay, so as I said, strictly speaking, theta is known as arg z, the argument of the complex number. But I'll explain that exactly as I go along. I need to be a little bit technical for a couple of seconds when we discuss it. They've only asked it once or twice for you to specifically write down what arg z is, but you need to know the definition, obviously, to get it right. Okay? Right, so here's our first example. Express minus 1 plus I in polar form. Okay? Now, an argand diagram. Isn't an argand diagram exactly like an x and y axis, except for the x-axis is now the real axis and the y-axis is now the imaginary axis? Okay, so we've just literally swapped our labels. Okay? So, here we go. We don't need to be too detailed about this, but we don't need to be too sloppy either. Okay, we need a little bit of detail. This guy is obviously the real axis, and this guy is obviously the imaginary axis. Now, you don't have to write down the full words real and imaginary. It's okay to write RE and IM. Is that okay? That's perfectly okay. Would you like to tell me what quadrant is minus 1 plus I in? It's in the second quadrant, isn't it? Isn't minus 1 plus I somewhere back over here? Everybody okay with that? So minus 1 plus I is somewhere over there. Okay? Now, to write it in polar form, I need to know what r is, and r means the distance from the complex number back to the origin. Is that okay? The distance from minus 1 plus I back to 0. Okay? So that's what r means. And then theta is the argument of z. So there's theta, that angle there. Is everybody okay with that? Now the only thing is, it's a little bit tricky, isn't it, to get theta straight away. I can't dive in immediately and get theta. What might be handy for me to do is to find this guy here, call him alpha. Because if I knew what alpha was, couldn't I just take him away from 180 and get theta? Okay? Whatever alpha is, take it away from 180, you've got theta. Now, first of all, always use tan. What's tan of alpha? Doesn't tan mean opposite over adjacent? But sure, isn't that just 1 over 1? Because it's minus 1 plus I. And minus 1 plus I means come back 1, go up 1. Okay? Minus 1 plus I. So tan of alpha is 1 over 1, which is 1. All agreed? So that means that alpha is, what's alpha? It's 45 degrees, isn't it? The tan of 45 is 1, so alpha must be 45 degrees. Okay? Now, what's theta? 180 minus 45, which is 135 degrees. Is that okay? So theta is 135 degrees. Okay? Now, just on a technicality, if you're asked to write down arg z, you must convert your angle into radians. Is that okay? So, I'm not asking it in the question, but arg z is 3 pi over 4 radians. Because isn't 135 degrees 3 pi over 4? For calculation purposes, from here on, it's perfectly okay for me to continue using 135 degrees. But to correctly answer the arg z question, I have to quote it in radians. Is that okay? I must quote it in radians. Everybody happy? Right. Now, I need r into cos theta plus I sine theta. I now know what theta is. I need to now calculate r. Okay? Doesn't r mean the modulus of the complex number? Isn't r the modulus of minus 1 plus I? Is that okay? The modulus of minus 1 plus I. Now, how do you find the modulus of a complex number? What's the formula for modulus? Isn't it the square root of a squared plus b squared? Isn't it? So what's the modulus of my complex number? Square root of minus 1 squared plus 1 squared. Now I'm going to make a comment now that I'm going to make several times today. Look underneath that square root sign. Everything is positive and there is no mention of I. Is that okay? I never gets a mention. There's no I in the formula. It's minus 1 squared plus 1 squared. It's only the number in front of I that you square. Is that okay? The coefficient of I is the only thing you square. So minus 1 squared plus 1 squared, which is root 2. Is that okay? So what have we got? Minus 1 plus I equals r into cos theta plus I sine theta. So that's equal to root 2 into cos of 135 plus I sine 135. It's okay to use degrees there. I know it's technically correct to use radians, but it's okay to use degrees. It works equally well. Okay? The only time you really have to use radians is if they ask you for arg z. Okay? So is everybody entirely okay with that question? Now, the next question has a little bit of a twist in it. Okay? Just a tiny twist. You probably won't even spot that there's a twist. Express minus 1 minus root 3i in polar form. Okay? And something vitally important is going to come up in this question. Something absolutely vital. Express minus 1 minus root 3i in polar form. Well, first of all, find me a quadrant. Where are we? Third quadrant. There's RE. There's IM. Minus 1 minus root 3i. Isn't that off down here somewhere? Everybody okay with that? Now, wouldn't theta mean this angle from here all the way around to here? Yes? So there's theta. Obviously, what I'm going to do is just like in the last question, I'm going to find out what alpha is. Okay? Now, usually alpha will turn out to be nice, handy angles. Would you agree that this is 1 and this is root 3? To plot minus 1 minus root 3i, you're going to go back 1 and down root 3. Is that okay? So what's tan alpha? Looking at my picture. Isn't it root 3 over 1? Opposite over adjacent. So tan of alpha equals root 3 over 1, which means that alpha equals 60 degrees. The tan of 60 is root 3. So alpha must be 60 degrees. So what does that make theta? Theta would, in this question, would you agree, is 180 plus 60. So you go from here to here, which is 180 degrees, and then you have to add alpha. So we've got to add 60. Okay, 180 plus 60 is 240. So theta equals 240 degrees. Is that okay? Now, I will be very impressed if anybody in the room can give me a correct answer to the next question. So I'm telling you, there's a little subtle catch. Write down what you think arg z is. So I'll stop talking for about 20 seconds while you're writing down arg z. Now remember, arg z must be quoted in what? Has to be in radians, doesn't it? We cannot use degrees here. We must convert to radians, but there's a bit more of a twist than that. Here's arg z. How many of you had that? How many of you had 4 pi over 3? I would say most people in the room. It's not technically correct. Arg z has to be between minus pi and plus pi. If the complex number, please don't forget this, if the complex number is above the real axis, you come around this way to the complex number. If the complex number is underneath the x-axis, the real axis, you've got to come this way. Is that okay? So if it's above the real axis, you've got to go from the real axis anti-clockwise till you get to the angle. But if it's below the real axis, to be technically correct, you've got to come down this way. Now, if this is 240 degrees, would you agree that this is 120 degrees? Yes? But because it's coming underneath, isn't it really minus 120? Yes? Sorry, did I write down minus pi over 3? Sorry, pi over 3. It should be minus 2 pi over 3, sorry. Because it's minus 120 degrees. Is that okay? Do you all understand that? Because obviously this angle here, from here around to here, is 120 degrees, if that's 240. Okay? It's just a tiny little complication. It'd only be a 5-mark question. Write down what arg z is. But if you get it wrong, you lose 3 marks at least. Is that okay? So just be a little bit careful about it. Do you get what I'm saying? If you're above the real axis, you go anti-clockwise. If you're below the real axis, you go clockwise. Is that okay? And it's a negative angle if you're coming down underneath here. Okay? So minus 2 pi over 3, that's arg z. Now, to be fair, for all other calculations, it's perfectly okay for us to go with our 240 degrees. It's only if they ask me what's arg z that I have to think about that. Okay? Now, next up, I need r, don't I? And r means the modulus of the complex number. So it's the modulus of minus 1 minus root 3i, which is the square root of minus 1 squared plus minus root 3 squared, isn't it? Again, do you notice there is no mention of I? Okay, no mention of I. Thanks a million, Connor. Have we all signed? Yep? No? Jessica, there you go. So that's going to be the square root of 1 plus 3, which is square root of 4, which is 2. Okay? So what's that mean? It means that our complex number minus 1 minus root 3i is equal to r into cos theta plus I sine theta. So that's going to be 2 into the cos of 240 plus I sine 240. Is that okay? Everybody all right? So that's the question totally done. Now, I want to save a little bit of time. Obviously, the next thing that's going to happen here is going to be the theorem of the Moivre, isn't it? Okay? I'm going to put a link at the end of the week. You're all going to be given a username and a password to log on to the website to look at different videos like what we're recording today and other videos as well. And I have another video with the proof of the Moivre theorem on it. So what I'll do is I'll upload that link as well. Is that okay? And then you can see me do the proof. I just don't want to waste the time today doing the proof. Is that okay? Not that it's a waste of time, but it's just with more important things to do. So, on to the Moivre. So, the Moivre theorem. Quoted simply, here's what it means. Cos theta plus I sine theta to the power of n equals what? The cos of n theta plus I sine n theta. So in other words, all you've got to do is get the power, bring it down, and multiply it by the angle. Is that okay? That's all you've got to do. So cos theta plus I sine theta to the power of n is cos n theta plus I sine n theta. So let's build up a nice leave insert question. Okay, typical part C. Right, part 1. Express 1 minus root 3i in polar form. So it's like what we've been doing up to now, plus. Okay, plus a few extra bits. Okay? Now, which quadrant would 1 minus root 3i live in? Fourth quadrant, isn't it? Okay, so if we put our axes there, again, this guy here is the real axis. This guy here is the imaginary axis. And 1 minus root 3i is going to be somewhere off down here. Okay? Now what have I got to do? I've got to figure out what is r and what is theta. Is that okay? What's r, what's theta? So r is obviously that distance there, isn't it? And then theta, my angle, this time it's going to be huge. Isn't it that entire angle there? Yes? But let's figure out what alpha is first, where alpha is this little small angle in here. Because if I knew what alpha was, I can obviously find theta in about a half a second. Okay? Now again, how do you always find alpha? This is 1 minus root 3i, so it's across 1 down root 3, isn't it? Okay? So what's tan of alpha? Isn't tan of alpha root 3 over 1? Which is 60 degrees. Yes? So what does that make theta? How many degrees is theta? 300 degrees, isn't it? Okay, obviously full circle is 360. So if alpha is 60, theta must be 300. So theta equals 300 degrees. It's a matter of interest. What's arg z? Everybody write down what they think arg z is. Is it a positive angle or is it a negative angle? Positive or negative? Negative. It's underneath the real axis, so no, we need to go clockwise. We need to go the wrong way around. How many degrees the wrong way around? 60. So technically, isn't arg z in our mind for thinking about it? We're thinking minus 60 degrees. But on paper, we're saying minus pi over 3 radians. Is that okay? We're quoting it in radians. Just again, in case they ask that question. Because remember, where does arg z always have to be? Between minus pi and plus pi. Is that okay? Has to be between minus pi and plus pi. Right, so anyway, theta is 300 for the rest of the question. Now r. R is the modulus of the complex number. So it's the modulus of 1 minus root 3i, which is the square root of 1 squared plus minus root 3 squared. I think everybody would be okay there if I wrote down 2, would we? It's obviously 1 and 3, which is 4. Square root of 4 is 2. So r is 2. So then we can say that 1 minus root 3i equals r into cos theta plus I sine theta. So 1 minus root 3i equals 2 into cos of 300 plus I sine 300. Sinead? It's easy, isn't it? You'd put in the plus. If you put in the plus, it's the only time that you'd worry about this minus business is if they ask you for R of Z. Okay, that is the only time that you stress yourself out about that. In all other situations, you just shove down what the angle is. Is that okay? So I don't mean to confuse you. It's just that 2 years ago, they did specifically ask, what is arg Z? Okay? So just in case, I want you to be making sure you're getting full marks on it. Okay? So anyway, that's part 1. 1 minus root 3i written in modulus argument form, or polar form. Right, part 2. Hence, find 1 minus root 3i to the power of 12 in its simplest form. And actually, do you know what? To make our lives a little bit more interesting, I'll change that 12 to a 13. Makes the question harder, not easier. Okay? Makes it slightly harder. You're probably wondering why. Just things work out too easy if it's 12. Obviously, when you see a power outside brackets, that's instantly telling you, use the Moivre theorem. Okay? So here goes. 1 minus root 3i to the power of 13. Think about it. Isn't it going to be the same as 2 to the power of 13, yes, multiplied by, you see this bit here? Am I going to have to put that to the power of 13 as well? Okay? So multiplied by the cos of 300 plus I sine 300 to the power of 13. Okay? Now, quite obviously, there's nothing I can do with this. I'll just leave it as 2 to the power of 13. Okay? There's not a lot I can do with it. So I'll just write down 2 to the power of 13 again. What does the Moivre theorem tell me to do with the power? Bring that power inside and multiply it by the angle. Now, when the 13 comes inside, 13 multiplied by 300 is 3,900. Okay, so that's 3,900 degrees. Plus I sine 3,900 degrees. Is that okay? So what did I do there? Now just write down on the right-hand side, actually, using the Moivre theorem, so that you're explaining to the examiner that you know exactly what's going on here. Okay? You're not just making guesses. So using the Moivre theorem. Now, this little bit of rough work that I'm going to do over on the right-hand side is of massive importance. Absolutely massive importance. How many degrees in a full circle? 360. So I'm going to divide 3,900 by 360. Now, I'll tell you the reason why I changed my 12 to a 13. What's 12 multiplied by 300? 3,600. Isn't that exactly a multiple of 360? So I made it a bit more awkward then, to make it not a multiple of 360. Here's the point I want to make. You are not interested in how many times 360 divides into it. You're only interested in what's left over. Is that okay? Would you write that down as well? You are only interested in what's left over when I do this division. Okay, how many times it goes in is irrelevant. You're only interested in the remainder. If you did that on your calculator, I presume your calculator is going to say to you 3 and 5/6. Okay, just double check. It is 3 and 5/6, isn't it? Yes? 3 and 5/6. Actually, it's not 3 and 5/6, it's 12 and 5/6. Sorry. 10 and 5/6. I don't care at all about the 10. Whether it was a 3 or a 12 would be irrelevant. The only thing of interest to me is the 5/6. Okay? How many degrees in a full circle? 360. Okay? So what's 5/6 of 360? Oh, we're back at 300 degrees again, aren't we? It's 300 degrees. Everybody okay with that? So in other words, the cos of 3,900 is the same as the cos of 300. The sine of 3,900 is the same as the sine of 300. We're just making it more realistic. Okay? So, with that in mind, that's going to be 2 to the power of 13. What's the cos of 300? It's a half. Sine of 300. Minus root 3 over 2. Okay? So the cos of 300 is a half. The sine of 300 is minus root 3 over 2. Remember, we are in the fourth quadrant where cos is positive and sine is negative. Okay? Now, do you notice that there's a 2 on the bottom here and a 2 on the bottom here? Couldn't I pull that common 2 outside the brackets? And what would that do to 2 to the power of 13? Wouldn't it make it 2 to the power of 12? Into 1 minus root 3i. Job done. Is that okay? That's it. Now, usually what they will do is they will say, write your answer in the form 2 to the power of n into a plus, a minus root b I, where a and b are an element of z. What does that mean? What does a and b an element of z mean? That they're integers. In other words, they could be positive, they could be negative, but they're definitely whole numbers. Is that okay? Now, is everybody 100% clear on everything that's happened so far today? Okay? So, if you're finding a complex number to the power of a number, your first job is get it into polar form. Get it into the form or into cos sine theta plus I sine theta. Next, use the Moivre. Okay? Then simplify if you can. And as I said, the critical thing here is that when you're doing your calculation on the angle, when you divide by 360, you're only interested in the remainder. Is that okay? You're only interested in the remainder, that's all. Okay, now this is where life gets tough. Okay? This is the worst case scenario for de Moivre. Now, before I do this question, if I keep walking around in circles, where do I end up? Back where I started. That's why I didn't care. Do you know the way it was 10 and 5/6? I didn't care whether that was 10 or 12 or 50 or a million. It didn't matter, because if I keep walking around in circles, I'm going to end up back where I started. Okay? So in other words, if I said to you, can you stand at 60 degrees, please? And then I say to someone else, can you go twice around the circle and stand at 60? And then I'll go 50 times around the circle and stand at 60. Won't the three of us be standing in the same place? Would you agree? The three of us would be standing in the exact same place. So here's the full version of polar form. Imagine our complex number is z. Z equals r into cos theta plus 360n plus I sine theta plus 360n. Now, really it's down to your teacher. Some teachers prefer degrees, some teachers prefer radians. Okay, I prefer radians, but I find most students prefer degrees. So I tend to stick to degrees. If you have a teacher who sticks with radians, it's going to be theta plus 2 pi n, or 2n pi. Is that okay? But it's the same thing, because 2 pi is 360 anyway, isn't it? Okay? What's n? That will be absolutely true as long as n is an element of, actually it doesn't have to be an element of n, I was going to write n. If it's an element of z, it'll work. Okay? As long as it's a whole number, it could be positive, it could be negative, it could be anything you want it to be, but it has to be a whole number. Okay? Are we all happy with what I'm saying? Now the question is, how do you recognize that you should worry about the plus 360n? And how do you recognize when you should ignore it? In the last question we did, didn't we find a complex number to the power of 13? Isn't 13 a whole number? No need for 360n. When is the only time you need to worry about the plus 360n? If the power is a fraction. Is that okay? So just write down, you only need worry about this if the power is a fraction. You only have to worry about this if the power is a fraction. You only have to worry about this if the power is a fraction. Okay, yeah, sorry, Jesse, can I get that back, please? Thank you. Anybody not signed it now at this stage? We all have? Yep, thank you. So sorry, we only need worry about this if the power is a fraction. Okay? Now also, I just passed by 2011 there, but just want to make the point that last year, complex numbers hardly featured on the Leaving Cert paper. They hardly featured at all. It was nearly all matrices. It'd be kind of surprising, wouldn't it, if that was to happen again this year? It'd be shocking. Okay? It'd be very, very, very unusual. So in other words, what I'm saying to you is I think it'd be a very good idea to learn your complex numbers this year because I think they're going to go in the reverse. Okay? Now, this question as well, I've had to go back all the way to 2006 to get one. Okay? 2006 is the most recent time that this nasty question has been asked. Okay? And given that you are the last year of this course, I just think you could get this. Okay? So here we go. 06. Question 4. I think from my mood you can see it's a C part. Now actually the interesting thing about this C part is that there are places where you don't bother about the 360n and there are places where you do. Okay? So let's do the places where you don't first. Right, part A. Minus 8 minus 8 root 3I in polar form. That's what they want me to do to start off with. Express minus 8 minus 8 root 3I in polar form. So first of all, what quadrant are we living in? Third. So quickly then we draw real axis, imaginary axis, and we're obviously sitting somewhere down here. And there's R. So where's theta? Doesn't theta go all the way around to there? Okay, now obviously they didn't ask me to find argz in 2006, but if they had of, would you agree that argz would be a negative? Wouldn't it? So there's theta, and obviously I'm going to find alpha first and then use that to get theta. Now, this complex number is minus 8 root 3I. So I'm going to have to go back 8 and down 8 root 3. Okay, back 8, down 8 root 3. So back 8, down 8 root 3. Now, tan of alpha. Tan of alpha is going to be opposite over adjacent, which is 8 root 3 divided by 8, which is root 3. Now, how many times have we heard that today? Does that mean that alpha is 60 degrees? Okay, they tend to just regurgitate the same angles over and over and over again. Okay, so alpha is 60. So what's theta? What's theta? Isn't it 240? Okay, it's quite obviously going to be 180 plus 60, which is 240. As a matter of interest, not asked, but what is argz? It's minus 2 pi over 3, isn't it? Because if this is 240, this again must be 120, mustn't it? And because it's underneath the real axis, it's minus 120, and 120 is 2 pi over 3. So just scribble it in. Argz equals minus 2 pi over 3. Are we all clear on why? Okay? Because it's underneath the real axis. Next up is R. What is R? Well, R is going to be the modulus of minus 8 minus 8 root 3 I. So R equals the square root of minus 8 squared plus minus 8 root 3 squared. Notice, sign in the middle is always plus, no mention of I for about the 40th time today. Minus 8 squared is 64, isn't it? So that's root 64. Now, can you tell me, what's 8 root 3 squared? 64 multiplied by 3, isn't it? If I square 8, I get 64. If I square the square root of 3, I get 3. And 3 times 64 is 192. Okay, so plus 192. Which is root 256. That's grand, or 16. They said okay, so R is 16. Everybody happy? Now, part 2. I'm going to leave it up to you to tell me whether or not I need to worry about this 360n business. Okay? So, part 2. Find minus 8 minus 8 root 3i to the power of 3. Okay, sorry, I forgot to obviously do something very important here. Minus 8 root 3i is going to be obviously be 16 into the cos of 240 plus I sine 240. Apologies, I found R, I found theta, but I didn't actually write it in polar form. Now I have. You'll notice that there I chose to ignore the 360n, didn't I? I didn't need to put in the 360n for part 1, definitely not. Do I need it for part 2? No. How do I know I don't? Power is a whole number. Because the power is a whole number, I can just write straight in with that. Okay? So here goes. That's going to be 16 to the power of 3 multiplied by the cos of 240 plus I sine 240 to the power of 3. 16 cubed, is that 4096? Yeah. Okay. 4096. The cos of 240 should be minus a half. Oh, sorry, jumping ahead of myself. Cos of 720 plus I sine 720. Sorry, I forgot to use Mr. Moivre. Obviously, what I did there was I brought the 3 inside and I multiplied it by the 240. Okay? Now, this is kind of nice, actually. 720 divided by 360 is just 2. Now, remember, I don't care whether it's 2 or 22 or 52 or a million or 2. All I'm concerned about is what's left over. But doesn't 360 go into 720 exactly twice? So isn't it the same as 0? Okay? It's the same as 0 degrees. So that's 4096 by the cos of 0 plus I sine 0. The cos of 0 is what? 1. And the sine of 0 is 0. So I don't need to worry. When the imaginary part is 0, I don't need to really concern myself about it. So it's 4096. Okay, the answer is entirely real. Okay, that's kind of straightforward question, isn't it? Okay. Now the next part is an awful lot harder. To a point. Okay, I suppose the main thing, as you probably gathered, that this is going to be the part where we need to stress out a little bit about the 360n. Okay? Having said that, the examiner is going to try to hide that fact from us. I'm actually going to make the question a little bit worse than what the examiner asked. I hope nobody has exam papers open, have you? Okay, I'm going to just put a little bit more of a twist. Hence solve that. Now actually the way they phrased it was find the 4 complex numbers. So they don't want you to just get one of them, they want you to get all 4. Okay? Would you agree this is a quartic equation? Quadratic equations will all have 2 roots. Now they might not be real, but they'll have 2 roots. They might be imaginary. Cubic equations will all have 3 roots. Quartic equations will all have 4 roots. And I think you've guessed it, quintic equations will all have 5 roots. Is that okay? Now, how is that similar to what we were asked? That's not our complex number, is it? No. How would you turn it into our complex number? If you brought it over the equal sign, it'd look more like it, wouldn't it? Okay, and that's actually what the examiner did. The examiner wrote this down. They said solve z to the power of 4 equals minus 8 root 3 I. In other words, the complex number that we just had. Okay? Now things are starting to look good. Now I'm going to say something probably about 400 times this week, and if you were here at Christmas, you've already heard me say it about 400 times. If you move something across an equal sign, what do? You replace it with its opposite. Okay? If you move something across an equal sign, you replace it with its opposite. If you haven't heard me say that before, can you please write it down now? If you move something across an equal sign, you replace it with its opposite. That was kind of the mantra we had at the Christmas course for differentiation and all the different things that we did. Okay? So what's the opposite of doing z to the power of 4? Like, this is off the Leaving Cert paper, just to kind of put it clear in your minds. There was one question about 15, 16 years ago, and you ended up with this. X to the power of 3 over 2 equals 8. Now, you had done a whole lot of maths to end up at that point. And you're obviously told, what's x? So if x to the power of 3 over 2 is 8, what's x? What happens to the power when it goes over? It turns upside down. Okay? Now, that's going to be, you have 2 choices. You can either do 8 to the power of 2 and get the cubed root of your answer, or you can get the cubed root of 8 and then square your answer. Now, easier to do the second option. Cubed root of 8 is 2, and 2 squared is 4. The important thing was what happened to the power when it went over the equal sign. Now, obviously, that has no connection with this question other than it answers what to do with the 4. What happens to z to the power of 4? It becomes to the power of a quarter. And now there's an alarm bell ringing in your head. What's it saying? 360n. Is that okay? So z equals minus 8 root 3 I to the power of a quarter. So it looked like part 2 and part 3 were very similar to each other. They're totally different. One of them has the 360n, one of them doesn't. So wouldn't it be wrong for me to write this down? That z equals 16 multiplied by, don't take this down because it's wrong, the cos of 240 plus I sine 240 to the power of a quarter. Wouldn't that be complete rubbish? Okay? All that would do is give me one answer. But we were asked to find all 4 solutions. You understand me? We were asked to get all 4 solutions. I don't want one solution, I want 4. So that was rubbish. Okay? Could not work in this case. So I have to get rid of that. Now, here's the correct way. 16 to the power of a quarter. And then the cost of 240 plus 360n plus I sine 240 plus 360n. To the power of a quarter. Is that okay with everybody in the room? What was the trigger that made me put in the 360n? Fraction. Is that okay? The power was a fraction. Okay? Now, bring the power in. First of all, 16 to the power of a quarter. We should know off the top of our heads what the 4th root of a quarter is. It's 2, isn't it? Really, in English, it means what number multiplied by itself 4 times gives me 16. The answer is obviously 2. Now, that 1 quarter. What's 1 quarter of 240? 60. So it's 2 into the cost of 60. And don't make this mistake. I also have to divide the 360n by 4. I have to multiply that by a quarter as well. So plus 90n plus I sine 60 plus 90n. Is that completely all right? And again, just write down on the right-hand side by de Moivre's theorem. So that's all down to Mr. de Moivre again. Okay? Now, what do I do now? What happens next? Everything that I do from here on comes from this formula. If I keep walking around in circles, I end up back where I started, yes? What I want to do here is I want to start on my circle, and I want to keep walking around my circle until I get 4 roots. But once I have my 4 roots, there's no point in me going around and around and around, is there? Once I have my 4 roots, let's stop, go off, have a cup of tea, and take a break. Okay? I only keep going till I get 4 roots. So what you do now is, this is from now on, actually, the pressure is off. All I got to do is put in any 4 consecutive numbers instead of n. Any 4. If that was to the power of a third, I put any 3 consecutive numbers. If that was to the power of 7, I put in any 7 consecutive numbers. It doesn't matter what the numbers are, as long as they're consecutive numbers. Okay? So, where better to start other than 0? If you decide to start at 1, you're going to have to go 1, 2, 3, 4. If I start at 0, I'll go 0, 1, 2, 3. Okay? Any 4 consecutive numbers. Will you write that down, please? We will now put in any 4 consecutive numbers instead of n. So that yellow equation, I'm going to try to keep it on the board because I'm going to be using that over and over again. This is boring calculator work from here on, thank God. Okay? Right, first of all, I'm going to begin by letting n equals 0. Okay, and I'm going to call the roots z1, z2, z3, z4. Is that okay? So first of all, z1. Well, isn't that going to be 2 multiplied by cos of 60 plus I sine 60? Isn't it? Because obviously if I put in 0 instead of n, what's 90 multiplied by 0? 0, so that's gone. Okay, so that's fine, that's obvious. What's the cost of 60? It's a half. Sine of 60 is root 3 over 2. I. So my first answer is 1 plus root 3i. So there's my first root, z1. Okay? Now, as I said, all I got to do is let n equal any 4 consecutive numbers. So now I'm going to let n equal 1. So what's z2 going to be? 2 multiplied by cos of what? What happens if I put in 1 instead of n? 90 by 1 is 90. 90 plus 60 is 150. Is that okay? So it's the cos of 150 plus I sine 150. Can you see I'm just going around the circle, haven't I? Now I've moved from the first quadrant into the second quadrant. Agreed? Now, would you agree that in the second quadrant cos is negative and sine is positive? And the answer is that this guy is going to be minus root 3 over 2 plus a half I. You can double check on me, but the cos of 150 is minus root 3 over 2 and the sine of 150 is a half. Okay? Now when I multiply that out, don't I get z2, my second root, is minus root 3 plus I. Is that okay? Now let's keep going. Next up, let n equal 2. So z3, isn't that going to be 2 into the cos of, well now let's put in 2 instead of n. 90 multiplied by 2 is 180. 180 plus 60 is 240. So cos 240. Plus I sine 240. Would you agree that both cos and sine are negative in this quadrant? We're in tan's quadrant now, aren't we? Where tan is positive, but sine and cos are both negative. And cos of that is minus a half. The sine of that is minus root 3 over 2. So that's minus 1 minus root 3 I. So there's my third root, z3. Okay? Now we go to the fourth root. N equals 3. So z4 is 2 into cos of what? 3 times 90 is 270. 270 plus 60 is 330. So cos 330 plus I sine 330. Now, who's positive in this quadrant? Cos is. So that's going to be root 3 over 2 minus a half I, which is root 3 minus I. So there's my Z4. Now, what would you think would happen? Just a matter of interest. I'm finished now, by the way. My question is over. I can go off now and do the differentiation question or whatever other question I'm doing. That question is over. But what would happen, would you think, if I now put n equals 4? What's 4 by 90? Ah, that's a full circle, isn't it? Doesn't that mean I'm just going to get this guy again? If I let n equals 5, if I let n equals 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, I'll just keep regurgitating those roots. Is that okay? So you only do it until you have all your roots, and then you stop. Okay? Now, I would have to say that question is probably the joint most important thing that we do today. Okay? Now, I also want you to look at the roots for a second, because I'm going to make another point now in a minute. Are the roots the conjugates of each other? I'm not saying they are, I'm just wondering, are they? No, they're not. They look kind of like each other. Like the conjugate means change the sign of the imaginary part, doesn't it? What's the comparison between this guy and this guy? Actually, both parts are opposite, so they're not conjugates. What about this and this? Well, again, both parts are opposites, so they're not conjugates. I knew before I even started the question that they weren't going to be the conjugates of each other. However, I'll ask you to do this at home. If you were to do this question at home, solve z cubed minus 8 equals 0, or plus 8 to make it a bit more interesting. I bet my house that the roots of that equation would be the conjugates of each other. How come? How come these ones would be the conjugates and the question we just did wouldn't be? It's actually, I thought someone was going to say that, it's not the difference between cubing and to the power of 4. It's not to do with the power. If that was z to the power of 4 plus 16 equals 0, the roots would still be conjugates. Here's the ruling. If you have a polynomial equation, okay, write all this sentence down, it's massively important. If you have a polynomial equation with real coefficients, if you have a polynomial equation with real coefficients, then the roots occur in conjugate pairs. Then the complex roots occur in conjugate pairs. If you have a polynomial equation with real coefficients, then the complex roots occur in conjugate pairs. Is that okay? The complex roots occur in conjugate pairs. So how come my roots did not occur in conjugate pairs? What equation was I solving? I was solving z to the power of 4 plus 8 root 3 I equals 0. If there's a mention of I in the equation, if there's an I in the equation, the roots won't be conjugate pairs. If everything is real in the equation, if there's no mention of I in the equation, then the roots will be conjugate pairs. Is that okay? To keep it even simpler. All right? So if you have a quadratic equation that doesn't mention I, the roots occur in conjugate pairs. If you have a quadratic equation where there is an I in it, the roots won't be conjugate pairs. Is that okay? Likewise for cubic equations, likewise for quartic equations, quintic equations, or whatever equation you like. Okay? Are we all happy enough with that? Now, please at home, would you solve that equation for me? Z cubed plus 8 equals 0. It's quite an easy question. It's much shorter than the one I just did. And just verify in your own mind that, yeah, you know what, the roots are conjugates of each other. Now, only the complex roots. The complex roots are the conjugates of each other. By the way, the question about arg z came up in 2010. Right, I'm going to do a variation on the 2011 question now, on last year's question. I'm going to again make it a little bit harder. What they did was they divided it up into two parts. And part 1 was relevant to part 2. I'm just going to dive straight in with part 2. Okay? To make life a little bit more complicated. Solve for x if x squared plus x plus 1 plus I equals 0. Solve for x if that's true. Would anybody like to tell me whether or not the roots of this will occur in conjugate pairs? Absolutely not. There's no way they're going to be conjugate pairs. Why? Because there's an I. If I left the I out of it, would they be conjugate pairs? Yes. Is that okay? But because it has an I in it, they're not going to be conjugate pairs. Okay? So if you end up with conjugate pairs, you've done something wrong. Okay? So how am I going to do this? Since first year in maths, when we've been confronted with quadratic equations, how have we solved them? Minus b plus or minus the square root of b squared minus 4ac all over 2a. So why change now? Okay, that formula works whether the coefficients are real or imaginary or whatever they are. It works. Here's an important comment. Anything that you can do to real numbers, you can also do to complex numbers. But it doesn't work the other way around. There are certain things you can do with complex numbers that you can't do with real numbers. But anything that you can do with real numbers, you can do that same thing with complex numbers. Okay? Because real numbers are a subset of complex numbers. Do you understand what I mean by that? It's like this. Would you agree? Everybody who was born in Dublin is Irish. Is everybody that was born in Ireland from Dublin? It's a bit like that. Okay? It's like real numbers are a small little gang and then complex numbers are a bigger set. Okay? Anyway. Get back to the point. X equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Tell me, what's a, what's b, what's c? A is 1, b is 1, and c is 1 plus I. Okay, so a is 1, b is 1, and c is 1 plus I. So x equals minus b, which is minus 1, plus or minus the square root of 1 squared minus 4 by 1 plus I all over 2a, which is 2. Now, there was one year, actually, about 2002, that they had something like ix squared, which gave another little headache because you had a 2i on the bottom. You had i's on the top and on the bottom, which made it a little bit harder again. Okay? How do you divide complex numbers? How do you do division of complex numbers? You multiply the top and bottom by the conjugate of the bottom line. You would have had to do that at the end in the question I'm thinking of, okay? Anyway, x equals minus 1 plus or minus the square root of 1 minus 4 minus 4i all divided by 2. So x equals minus 1 plus or minus minus 3 minus 4i all over 2. Now, I've just actually noticed something small. I've actually taken the question down slightly incorrectly. See this? That's a minus. So sorry. That's a minus. Makes that plus. Makes that plus. Is that all right? Sorry, I just accidentally didn't see the minus sign when I looked down. Is that all right? It doesn't make any major impact to the question other than it changes a few signs coming down along here. Okay? So we all happy with what we see? Now, the only thing that's wrecking my head now is, what is this? What's the square root of minus 3 plus 4i? How do I get the square root of a complex number? When you don't know what something is in maths, what do you call it? You'd usually call it x or something, wouldn't you? When you don't know what a complex number is, you have to think, well, you know what? It might have a real part and it might have an imaginary part. So what I'm going to do is, I don't know what the square root of minus 3 plus 4i is. I'm going to do this. I'm going to say, let a plus bi be the square root of minus 3 plus 4i. Is that okay? Let a plus bi equal to it. We all right? Now, how would you get rid of square root signs? Square both sides. So let's square. Doesn't that mean that a plus bi squared equals minus 3 plus 4i? We all agreed on that? Now, do you remember the way I said I went straight for part 2? I skipped part 1. What was part 1, would you think? Find the real numbers a and b such that a plus bi to be squared equals minus 3 plus 4i. Is that okay? It was basically solve that. So I'm actually now doing part 1. Okay? Obviously, whatever answer I get here, am I going to just suddenly put it in here? Okay? To finish off this part. But that's the reason why they made you do part 1. So anyway, square it out. Square the first, a squared. Multiply the first by the second and double your answer. 2abi. Square the last, b squared, I squared. Minus 3 plus 4i. What's I squared? I squared is minus 1. So what's b squared I squared? Minus b squared. Okay? So don't I now have a squared plus 2abi minus b squared equals minus 3 plus 4i. What do I do next? Let the real on the left equal real on the right, and imaginary on the left equal imaginary on the right. So I equate the real parts and I equate the imaginary parts. So first of all, the real bits. A squared minus b squared equals minus 3. Basically, the real bits are anything that doesn't have an I in it now. Okay? So a squared minus b squared equals minus 3. The imaginary parts. It's much easier. 2ab on the left equals 4 on the right. You don't need to include the I. You don't have to say 2abi equals 4i. Okay? It's fine to do what I did. So if 2ab equals 4, doesn't that mean that ab equals 2? Which means that b equals 2 over a. Is that okay? So b is 2 over a. Now what? 2 over a back here instead of b. Okay, so just swap that across really. So we've got a squared minus 4 over a squared equals minus 3. Now I don't like that a squared on the bottom. Tell me how to get rid of it. Just multiply across. A to the power of 4 minus 4 equals minus 3 a squared. So a to the power of 4 plus 3a squared minus 4 equals 0. Now, obviously that is a quartic equation, isn't it? But can't I solve it using quadratics? Couldn't I factorize it as a quadratic equation? So what would I get? I'd get a squared and a squared would give me a to the power of 4. And a squared plus 4 and a squared minus 1 would do it, wouldn't it? Yeah? 4 multiplied by minus 1 is minus 4, and 4 minus 1 is 3. Perfect. Okay, so that's on the button. Now, if this is true, doesn't that mean that a squared equals minus 4 or a squared equals 1? Happy? But the thing is, isn't it impossible for a squared to be equal to minus 4? If you square any real number, don't you get a positive answer? So it is absolutely impossible for a squared to be negative. There's no way that a squared could be equal to minus 4, so we have to get that one out of the way straight away. Now, it is possible for a to be 1, a squared to be 1, if a was plus or minus 1. Is that okay? So now I need to worry about b. If a equals 1, b equals 2 over a, which is 2. And if a equals minus 1, then b equals 2 over minus 1, which is minus 2. Is that all right? So b is 2 or b is minus 2. Now, in part 1, what I was actually asked was, find two complex numbers, a plus bi, such that this is true. So option number 1 is 1 plus 2i, and option number 2 is minus 1 minus 2i. Is that okay? So there's my two complex numbers there that they were looking for. 1 plus 2i or minus 1 minus 2i. Are we all okay with that? Do you notice this? That they're exactly the same as each other except opposite in sign. Yes? Do you notice that there's a plus or minus here? That question over there is done now. That's part 1 out of the way. To finish off part 2, I pick my favorite one of the two of those. I don't have to put both of them up here. I pick my favorite one and I put it in there. I do not have to pick both. Why don't I? Because it is plus or minus here. Is that okay? So I don't have to put both of them in, just one of them. Now again, the second one has minus signs in it, so I'm going to take the lazy approach and I'm going to do the one that has no minus signs. Okay? So x equals minus 1 plus or minus 1 plus 2i divided by 2. So all of that effort over on the right-hand side was just to find something that I could put in instead of the square root of minus 3 plus 4i. That's all. So here goes. X equals minus 1 plus 1 plus 2i over 2, or x equals minus 1 minus 1 minus 2i all over 2. Now before I go on, am I expecting conjugates here? I'm not, because there was an I in the equation at the start, wasn't there? So I'm definitely not expecting conjugates. So x equals minus 1 plus 1 cancels. 2i over 2 is I, or minus 2 minus 2i over 2. So the second option is minus 1 minus I. So there we go, job done. So either x is I or x is minus 1 minus I. That question took a long time, didn't it? It's a slow, slow question. The main thing there is just don't rush it, don't make silly mistakes, or you will suffer. Okay, take your time at it, don't rush it. You see, the thing is, if I had rushed it up here, I would quite likely, I would have ended up with a quadratic equation that I couldn't factorize. And then you see that would stop me from getting all of this stuff down here, wouldn't it? So just take your time at it, okay? Be methodical about it, don't rush it. So remind me again, what dictates whether or not roots are in conjugate pairs? Whether or not there's an I in the equation. Is that okay? Now, last 5 minutes. Here's something massively important. Okay? And it's kind of, it opens up a lot of the really, really interesting uses of complex numbers. Now, I am particularly speaking to people in the project schools now. Okay? However, this could also come up for people in normal schools. Okay? Anyone could be asked this. Okay? Now, if Z is a complex number such that any of you in the project schools will have had a very, very good look at last year's paper, and you'll have seen this question. If Z is a complex number such that the modulus of Z is greater than 1, and Z squared, and Z cubed are shown on the following diagram. So here's the interesting bit. There's your real axis, your imaginary axis. Indicate which is which. So I have drawn an Argand diagram. I've plotted 3 complex numbers on it, haven't I? One of them is Z, the other one is Z squared, and the other one is Z cubed. One is Z squared, and one is Z cubed. Which is which? Off you go, mark them. Mark what you think it is, but mark it in pencil. See this one here? This is Z. This is Z squared. That's Z cubed. How the hell did I know that? How did I know it? What told me that? Something subtle thrown in here. This bit. What's a unit circle? A unit circle is a circle of center 0, 0 and radius 1. The fact that the modulus of z is bigger than 1 does not mean that z is outside the unit circle. Doesn't it? If a complex number is outside a unit circle and you raise it to a higher power, it gets further and further and further away from O. If a complex number is inside the unit circle and you raise it to a higher power, what happens? It gets nearer and nearer and nearer to O. Or the way I phrase it to my own students here in the school, if you're outside a unit circle and you raise it to a higher power, it spirals out. Spirals outwards. Can you see a kind of a spiral going on here? Z to the power of 4, Z to the power of 5, Z to the power of 6, Z to the power of 7. It's spiraling out. Okay? If you start off inside the unit circle, you spiral in. Okay? So because it was outside the unit circle, the nearest one is Z and the furthest one is Z cubed. Okay? Now, I'm not going to write out the full question because we don't have time. But if the modulus of Z had been less than 1, what would you say? If the modulus of Z was smaller than 1, in other words, if I was starting off inside the unit circle, the one furthest away from the origin would be Z, okay? So furthest away would be Z, middle one would be Z squared, and the nearest would be Z cubed. Is that okay? So if you start off outside the unit circle, you spiral out. Start off inside, you spiral in. Okay, now that was part of last year's complex numbers question on the project paper, or it could have been on a sample paper. But that was what you were expected to know. The difference between beginning outside or inside our unit circle. Okay? Now, does anybody have any questions? Are we all okay?